So today we're starting our unit on polyhedrons. A polyhedron is 4 or more polygons that intersect at their edges. So I want you to think about the edge of a book where they meet. We're talking about the edges of a polygon. So guys, we have 5 regular polygons, and in these 5 regular polygons, all of their faces, and guys, a face is what you can touch. If it's seated on the desk, the faces are what you can touch around the sides. All of their faces are the same, which means they are congruent, regular polygons, and all of their vertices must have the same number of polygons meeting at each vertex in the same way. So we have 5 different types: tetra, hexa, octa, dodeca, and isohedron. So these are named based off of their faces. So a tetrahedron has 4 equilateral triangular faces. Hexa has 6 square faces. Octa has 8 equilateral triangular faces. Dodecahedron is 12 regular pentagonal faces. And then isohedron is 20 equilateral triangular faces. So guys, in class we will have 3-dimensional shapes. We will look at each of those shapes and how their vertices meet. So this is just the vocab or the wording behind what we would look at in class of a 3-dimensional shape. So guys, when you're talking about a 3-dimensional shape, we are still using the exact same formulas that you have been using since Algebra 1. So here, the length of a diagonal of a right rectangular prism. All right, so we know that the sides are rectangular. And notice that the diagonal goes from one side of the prism to the other. But in a 3-dimensional shape, you have ordered triples. So now instead of just the X and the Y, we now have a Z. Because think about, a 3-dimensional shape has a length, a width, and a height. So therefore, we now have, for ordered triples, we're going to incorporate the Z. So when we're talking about distance, we're going to find the distance of our X values, add them to the distance of our Y values, and now we're going to add it to the distance of our Z values. So guys, before this unit, this was your distance formula. We would find the length of the diagonal using the regular distance formula, but because they are 3-dimensional shapes, we now have that ordered triple. The same goes for midpoint. We're going to find the average of our X's, the average of our Y's, and now the average of our Z. So anytime we have a 3-dimensional shape, you will have ordered triples. Okay, so let's put all of these words into a mathematical problem. So the first 3-dimensional shape worksheet that you have for homework will ask you to find the midpoint and the length between the 2 points. So you're given point A is 6, 11, and 3. So notice now, instead of an ordered pair, we have an ordered triple. And then point B, 4, 9, and 7. So guys, just like before, average your X, average your Y, now average your Z. And so you're going to do the exact same thing for distance. The distance between 6 and 4 is 2. You're going to square it. The distance between 11 and 9 is 2, and you're going to square it. And then the distance between 3 and 7 is 4, and you'll square it. 4 plus 4 plus 16 is 24. Simplify your radical, giving you 2 square roots of 6. So again, we're still using midpoint and distance formulas, except now we're incorporating the Z value, an ordered triple. All right, so example 2 is the exact same way. X, Y, and a Z. X, Y, and a Z. You would find your midpoint, averaging your X's, your Y's, and your Z's. And you would find your distance between each of those values and then reduce your radical. So let's put that into a 3-dimensional shape. Your length, your width, and your height. So if I were to ask you to find the length of this diagonal, so for my visual learners, I would definitely highlight this. So here, we're not subtracting any values because we know the distance of the length. We know the distance of the width, and we know the distance of the height. So you would take those exact values, 4 and square it, 5 and square it, 2 and square it. Because remember, when we did this above, you were averaging those 2 points and then squaring the value. Well, here, they're telling you the average. And then again, reduce your radicals. Square root of 45 gives you 3 square roots of 5.